All right, so I want to do a few more examples. In my video where we talked about the area between curves, we typically, not always, but we typically, when we have an integral, let me turn on my writing tool here, when we have an integral from a to b of f of x, right? In that video, we said that a and b are where the curves meet. And typically when we're looking for a point where, when we're looking for the area between two curves, typically that is true. When we're looking for the area between two curves, that's typically true. However, sometimes we'll have curves that don't meet. Okay, so here's an example. Find the area between x squared and x squared plus 3. Now, I want you to picture these. I'm going to graph x squared in red. I'm going to graph x squared plus 3 in blue. X squared, if I draw my xy axes here, is going to look something like this. It's going to start at the origin and be very symmetric and go up in both directions, right? X squared plus 3, right? There's 3. No, there's not 3. Let's try that again. There's 3. And this guy's going to basically make the same shape. And these curves are never going to touch. Okay? And so you cannot apply this theory where A and B meet to curves that don't meet. Okay? So when you've got a situation like this, you will get some more information. And it will either be a set of numbers, a beginning and an end, or it will be something like this. So it'll give you two functions. It'll say x squared and x plus 3. And then it'll say x equals 1 and x equals 2. And now what they've done is they've given you 1, 2. And they've given you the region where they want the area. Okay? So sometimes you'll be given that instead of having to find the intersection point. This is actually an easier problem. So because we're trying to find the area, this is our left bound. So let me write this down. This is our left bound. And this is our right bound. If you watched my earlier video, you know that the left bound and the right bound will be your limits of integration. And so that immediately this left bound becomes A and this right bound becomes B. Okay? And so you can now find this integral. So what do? Well, our top function, right, remember our formula, integral of a to b of g of x minus f of x dx. And we said specifically that g had to be the top function and f had to be the bottom function. Okay? And so if I extend this to my given problem, my integral from a to b is going to be from 1 to 2. My top function is going to be x plus 3. And my bottom function is going to be x squared plus 3. And my bottom function is going to be x squared dx. Now, I'm going to go ahead and combine like terms here. X squared minus x squared is 0. So this becomes an integral from 1 to 2 of 3 dx, which becomes 3x evaluated from 1 to 2, which becomes what? 3 times 2 minus 3 times 1, right? So the top minus the bottom. Okay, well that's going to be 6 minus 3, which is 3. Okay, the area between these curves is 3 units. Now, what 3 units? Well, it could be meters squared, it could be feet squared, it could be centimeters squared. That depends on the context of the problem. But it could be power. It could be total cost. Remember, these things represent a ton of different things, okay? So, anyway, just wanted to kind of give you that. Now, let's try one more. Find the area in the region bounded by, and they'll give us a couple of functions here, okay? Y equals x squared and y equals the square root of x. Okay? Y equals x squared and y equals the square root of x. Okay? Now, they did not give us left and right endpoints. So we have to find these. Now, here's what we know. Okay? Here's what we know. If you recall x squared, right? So if you think of x squared, these both start. So both of these start. I'll write this down. They both start at 0, 0. Okay, they both start at 0, 0. And if you remember this guy, if you think of y equals square root of x, right? If you think of an xy table, if you think of an xy table of values, when x is 0, y is 0. We know when x is 1, y is 1. And we know when x is 4, y is 2, right? So, and it looks something like that. And then over here, if we do an xy table, we know that when x is 0, y is 0, right? This goes through the origin. And then what, right? Well, when x is 1, y is 1. And when x is 2, y is 4. And when x is 3, y is 9. And so what does that look like for us? Well, you already know where they intersect. And this guy, what does he look like? Remember, he looks like, and we're only focusing on this right-hand side. So if I think of this, right, we have x squared, and we have square root of x. Something like that, right? Okay? Something like that. And what do we know? Just by looking at these two tables, we know that our intersections are x equals 0 and x equals 1. Right? X equals 0 and x equals 1. Okay? What if we had to find these algebraically? Okay? If we had to find these algebraically, you'd say x squared equals square root of x. Okay? X squared equals the square root of x. And then you've got a couple of options. You could move the square root of x to the left-hand side, set it equal to 0. You could take the square root of both sides, or you could square both sides. Now, I'm going to be lazy, and I'm going to square both sides. So if I were to do that, get my pen to work here, and not, there we go, square both sides, what do we get? We get x to the 4th equal to x. Now, move this guy over. So what do we get? We get x to the 4th minus x equals 0. And we're going to do a little factoring here. So we're going to say x times x cubed minus 1 equals 0. Set that equal to 0. And set that equal to 0. and we get x equals, no, we don't get that. We get x equals 1 and x equals 0. So if you know what these graphs look like, you can find them without any work, or you can actually find them algebraically. Okay, so back to our problem at hand. How do we find the area between these? Well, we're going to do an integration. So we're going to say the integral from a to b of g of x minus f of x dx, right? And g has to be the top function, f has to be the bottom, and the way I've drawn this, I'm pretty sure x squared is the bottom and the square root of x is the top, because they intersect here, and then he goes underneath, and then they intersect again, okay? So this is going to be, our left bound will be 0, our right bound will be 1. G of x be our top function, so square root of x minus x squared dx. Okay, well, that breaks this into an integral and an integral of its own. Okay, and we can do that. That's pretty simple. So basically integrate the first function, integrate the second function, because there's no like terms to combine. So if we integrate these two functions, well, let's start with x squared. He's really easy, right? Because he's going to be negative 1/3 x cubed. And then square root of x, I come over here and say, listen, that's really just x to the 1/2, right? X to the 1/2. And the integral of x to the 1/2, let's put this in blue, integral of x to the 1/2 is going to be what? Well, you're going to add 1. So that's going to be x to the 3/2, right? X to the 3/2. Problem is if we put x to the 3/2, when we take the derivative, we multiply by 3/2, we're not going to get a 1 there. So we have to add a coefficient of 2/3. Okay, so that's pretty messy, but that's kind of my what I call side work. Okay, so this will be 2/3 x to the 3/2, or if you want to write it a different way, right? That would be 2/3 x root x minus 1/3 x cubed. Whichever one makes you happier. Okay, at this point, you could write it either way. If you were not allowed to do rational exponents, you'd have to write it the way I wrote it on the bottom. And just make sure you know 3/2, right? That's the same as 1 and 1/2. So 1 whole, right? So that's x to the first, and that's x to the 1/2. So that's where the quote-unquote 1 and 1/2 come from, right? So x to the first, x to the half, okay? And that's going to be evaluated where? From 0 to 1, okay? So what do we know? We're going to get 2/3 times 1 times the square root of 1 minus 1/3 times 1 cubed minus, so that's with plugging in 1, and now this one's going to be with plugging in 0, and what do we get? Oh, we get 2/3 times 0 square root of 0 minus 1/3 times 0 squared. All of that's just going to be 0. So it doesn't have any effect whatsoever. So then what do we get? Well, 1 times the square root of 1 is 1. So this just gives me 2/3 minus 1/3, which is 1/3. Okay, so the area bounded, let me scroll back to my original picture. Actually, let me just go ahead and draw this again, right? So here's my function, and I'll draw this guy in green, square root of x, and this guy in purple, x squared. This area, okay, this area right here, this area in yellow, is 1/3. Okay, it's a very, very small area. So if you wanted to find that area, that's how we do that. Hopefully that's helpful to you. And then one more, which is I want to find an average value of a function. Okay, find the average value of a function. Okay, so let's find the average value of a function. Let's say find the average value of f of x equals 4 minus x squared, 0 to, let's say 2, 0 to 2, okay? So what do we know? We know that this is going to be a, our left bound. This is going to be b, our right bound. And so we're going to say the integral from a to b of f of x dx, and that's going to be times 1 over b minus a. Oops, not actually put the letter a. Let's put what a equals, which is 0. My touch screen's not liking me today for some reason. Okay, so let's try that again. 0. There we go. And that's all equal to y average. Okay, so that's how we find this average value. So, well, I know that's just 1/2. And I've got to find this integral. Okay, so this integral here is going to be the integral of 4, which is 4x. And the integral of x squared will be negative 1/3 x cubed. And that's evaluated from 0 to 2. And this is going to be equal to 1/2 times and right, this guy goes here and 2 goes here. And I know that because both of these have an x, this whole thing's just going to be 0. So this is going to make my life a little easier. So this side's going to be 4 times 2 minus 1/3 times 2 cubed. And then all of that will be times 1/2. Well, 4 times 2 is 8. And 2 cubed is 8. So that's going to be minus 8/3. And then, of course, minus 0. So I just ignore that right-hand side there. Bring down the 1/2. And then I need to find a common denominator, right? And of course, that common denominator is going to be 8. So I'm going to multiply this will be 8 over 1. Multiply those by 3. So I get 1/2 times 24/3 minus 8/3, which is going to equal 1/2 times 16/3. And then, of course, this 2 and this 16, right? 16 divided by 2 gives me what? 8/3. And so that average value, that's my y average for this function, is 8/3. Y average is 8/3. Okay? And if you were to actually graph this on a graphing calculator, what you're looking for is the highest point would be above 8/3 and the lowest point would be below 8/3. Okay? That's how you know you found the appropriate y average. So anyway, just some more examples of finding the area between curves and finding the average value. If you have any questions, let me know.